Good morning, this is your Stat Sensei, Mr. Spensei, and this is a death packet on chi-squared and regression, and this will be regression problems 61 through 70. So researchers investigating the relationship between the length in centimeters and weight in grams of pineapples. The researchers will select a random sample of 15 pineapples from the grocery stores in a region and construct a 95% confidence interval for the slope of the population regression line, where the length is the explanatory variable. So length is explanatory variable and weight is the response variable. When computing a confidence interval for the slope of the population regression line, which of the following is not a condition that must be checked? First off, we do have to check linearity. All right. Um, we have to check homoscedasticity. In other words, we can't have a variation um, as our weight changes, we can't have a variation. We don't want to see the data getting real spread apart or real close together. So we can't have a variation. We should have randomness as far as our variation. The values of weight are approximately normally distributed at each value. That's very difficult to show, but that's also true. We need to check for normality. The sum of the residuals is zero. This is false. The sum of the residuals will be zero every time we run one of these tests. That's not a condition we need to check for. That's my answer. And obviously, we are going to have independent uh, we're going to have independent observations. Number 62, a marketing consultant, Sophia, has been studying the effect of increasing advertising spending on her product sales. Sophia conducts several experiments, each time spending less than $1,000 in advertising. When she analyzed the relationship between X equal to advertising spending and Y equal to product sales, the relationship was linear with an R equals 0.9. That's a pretty high linear relationship. Her boss is thrilled and asked her to estimate product sales for 100,000 in advertising budget. Is this appropriate for her to calculate a predicted amount of product sales with advertising spending of 100,000? And the answer, well, we've never spent more than 1,000 in advertising, so we can't say that for about 100,000. So the answer is no, because 100,000 is much greater than the values used in the experiment. So our best answer choice is E. We chose values outside of our limits. So 63, a study is made relating power and cold cranking amps of auto batteries as a function of price in dollars. Data from a sample of 13 batteries generates the following computer output. Which of the following gives a 90% confidence interval for the slope of the regression line? Well, first off, we need to identify our slope. Well, our slope is right here because it's always below our constant. So 5.52979, and I guess I should write our slope formula, which is b plus or minus b plus or minus t star times the standard error of the slope. So 5.592979 plus or minus. We know our standard error of our slope. We're going to look down on our slope line and we'll leave the space for t star and we'll come back to that. And we have 1.135. So real quickly, we've gotten rid of those. All right. But now we need to calculate T star. Well, we're going to go second vars inverse T. And in this case, we have parenthesis 1 minus 0.90 because I wanted a 90% confidence interval divided by 2. And our degrees of freedom are going to be based on the sample size, so 13 minus 1. And we get 1.7822. Well, that's interesting. Oh, um, I did not type in let me do that again. Second vars, inverse T, degrees of freedom. Degrees of freedom for slope is n minus 2, and I typed in 13 minus 1. So I need to change that to 13 minus 2. There we go. and we get 1.7958. And obviously the closest one to that is E. All right, in a random sample of 25 high school students, each was interviewed as to GPA and weekly hours worked at a part-time jobs. What is the critical T value in calculating a 90% confidence interval for the slope of the least squares regression line? All right. So we want to calculate a confidence interval. And so when they say the T value, what they're really asking for in this case is T star. Well, we know we're going to have to go 1 minus 0.90 divided by 2. And our degrees of freedom are going to be n minus 2, which in this case is 25 minus 2. So second vars, inverse T, already have for 90% from the previous problem. And then I'm going to go 25 minus 2, which is 23. And we get 1.7138. And the one that's closest, because I'm going to write that down, 1.7138. And the closest one is E. All right, 65. A regression analysis on the relationship between average annual profits and millions of dollars of insurance companies and the yearly number of major natural disasters. It gives the following output. If the analysis was rerun using number of disasters as the dependent variable instead of profits, what would be the correlation coefficient? Well, all we did was say, hey, if we switch the y and x, is our correlation going to change? And the answer is no, the correlation doesn't change. So if you have y hat equals some number, well, here, we'll write it out. In this case, we'd have y hat equals 420.727 minus 2.70909x. If you swap the y and x, you're going to end up with the same correlation coefficient. All right, so the correlation coefficient is not going to change, but we need to figure it out. Well, to do that, we need to find our slope, the sign of our slope. So we know the correlation is negative. So we're going to have a negative slope, and we need to look at our r squared. So r squared is 0.465. And I need to raise it to the 1/2 power. So the negative sign from the slope and the r squared to the 1/2 power, because r squared equals 0.465. And if I take the square root of it, I end up getting r. So the square root of 0.465. 0.465 raised to the 1/2 power gives me 0.681, and we already said it was negative because the slope is negative. Negative 0.6819, the closest value, is E, all right, because it's a negative, not the positive. Okay, number 66. Which is the correct scatter plot for the computer output to the right? Okay, so first off, when I look at my r squared, it's 0.906. And actually, let's deal with our slope. First off, my slope is negative. So this one goes away because it's a positive slope. This has a positive slope. These have negatives, right? We know we're looking for a negative slope. Well, my r squared is 0.906. So my correlation is going to be 0.906 raised to the 1/2 power. Because once again, r squared equals 0.906. And that will give me my r. And in this case, my r is 0.95, which means I have a very strong correlation. Well, the fact that I have a strong correlation, that gets rid of D. The next thing I said, oh, my constant is 10. That's my y-intercept. Well, this has a y-intercept of about 5. This has a y-intercept of maybe 7 or 8. And this one has a y-intercept of 10. That's what I'm looking for. All right, so the answer choice to 66 is C. 67. An automotive insurance company is interested in association between age of SUVs and odometer reading for their clients. Data from 20 randomly selected clients generates the following computer output. Which of the following gives a 96% confidence interval for the slope of the regression line? And they told us our sample size was n equals 20. Okay, so first off, I need to find my constant. That's my y-intercept, but we don't need that because we need our formula is b plus or minus t star standard error of the slope. Well, in this case, b is my slope. Well, this is my slope value because it's always below the below, so it's going to be below the constant, which is 15,675.2. But I don't have a 0.2 on any of these. But that gets rid of these three. Plus or minus, we'll come back and calculate t star, and we're going to continue looking down that slope row until we get our standard error of the slope. And my standard error, my slope happens to be 1,678. So right now we know it's this, because that's the only one that has that. But let's go ahead and calculate t star. So second vars inverse t, parenthesis 1 minus 0.96, close the parenthesis, divide by 2, and our sample size is 20. So degrees of freedom is 20 minus 2. And we end up getting 2.2137. And the one that's closest, of course, is E, as we already said. Number 68. Below is the computer output for regression analysis involving starting salary in thousands. And call it GPA. What is the equation for the least squares regression line? Well, honestly, I have trouble telling whether or not this was GPA, was predicted salary, or whatever. But when I look at this, this tells me, oh, that's my X variable. All right, if my GPA is my X variable, great. So that means if that's my X variable, the other was salary, we're going to have salary hat, so we can get rid of this. So those two are gone. And we know that that's my y-intercept. So we're going to have salary hat equals negative 0.73391. And our GPA is positive, so plus 11.8204. I should have said our slope is positive because this is my slope, times GPA. All right. So which one has that? Well, the only one that even had the right y-intercept was B. So 68 must be B. All right, 69. A theater owner believes that attendance actually goes up if the best seats are advertised for higher prices. Below is the computer printout for the regression analysis of attendance in the thousands of dollars versus price in dollars of the seats. What is the p-value of the test with beta equal to 0? And the alternative is beta is greater than 0. All right. So this is tricky. Okay. So whenever they run this, people want to go, oh, this is my p-value. All right. But this is the p-value based on a two-tail test. All right. So let's look at that. And I'm going to go ahead and subtract that from 1. 1 minus 0.0478. And that gives me 0.9528. So I went 1 minus the 0.0478. That's what gave me that. And I'm going to take that 0.0478 and divide it by 2. And so that's 0.0239. So that tells me, because your p-value is the area in the tails. Whenever they do this regression, it's always done as a not equal to. And so that tells me I have 0.0239 in both tails. Well, if I change it to a greater than, then I just have this area right here. And so my p-value becomes smaller. The 0.0478 is for a not equal to. Pretty tricky, I have to admit. Number 70, bankers at a large financial institution created the linear regression model d hat equals 0.37 minus 0.004s to predict the proportion of customers who would default on their loans based on the customer's credit score. For customer scores with a credit score of 700, which is true. All right, so we're going to go d hat equals 0.37 minus 0.0004 times our score of 700. So I'm going to plug that into the calculator. And by now you're going, of course you are. 0.37 minus 0.0004 parenthesis 700. And I end up getting 0.09. So D hat, or my predicted, is 0.09. All right. Um, so I have two different choices that have 0.09, so we can get rid of these because these are the two. Well, this says the default proportion will be. No, I don't like the word will. Is expected to be, is predicted to be. We think it will be. We predict it will be. It's expected to be based on our sample. It could vary a little bit, but this is what we're actually predicting to happen. All right. Doesn't mean it will, but it's what we're predicting to happen. All right. I appreciate you watching and look forward to seeing you on the next one. Thank you.